Okay, now we can continue with lecture number 4. Bale? Okay. Now we are going to go to the chapter 3 from the wireless communication by Theodore Rappaport. In this chapter, we are going to talk about in detail about the cellular communication. At the beginning, we are going to talk about the general structure, frequency reuse, system capacity. Then we have different strategies for the channel assignment. And then we are going to study the interference in the cellular communication system. And finally, we have techniques by which we can estimate the capacity of the system based on predicted grade of service and a specific number of channels. And the chapter will be ended by an important topic, which is how we are going to improve the capacity of the cellular communication system. So in this lecture today, inshallah, we are going to talk about the frequency reuse concept, which is the main concept in the cellular communication. Now let us start. Now, the cellular concept. Now, what is the basic objective? Okay, the design objective of the early mobile systems was to achieve large coverage area by using a single high power transmitter with antenna mounted on a tall tower. That was what about the early generations of the wireless communication. Now, this approach, still I'm talking about the early, achieved very good coverage. Yes, it's also meant that it was impossible to reuse those same frequencies throughout the system, since any attempt to achieve frequency reuse would result in what? In interference. Whenever we are talking about large coverage area, it will be impossible to reuse the frequency. Of course, when you talk about reusing the frequency, it means reusing the whole bandwidth. Now, step by step, we are going to understand what we mean by the frequency reuse. Just we are going to focus on the previous generation, which was large area. Every tower provides coverage for large areas. So doing that, it will prevent us to make frequency reuse or bandwidth reuse. Now, in 1970, the Bell mobile system in New York City could only support a maximum of 12 simultaneous calls over 1,000 square miles. Okay, so at the same, when talk about simultaneous, means at the same time. Okay, at the same time, all we have is what? 12 calls, no more. Well, faced with the fact that government regulatory agencies couldn't make spectrum allocation in proportion to the increasing demand for the mobile services. Keep in your mind always, in any communication system, okay, in any communication system, the limited resource is the bandwidth. Okay, the main problem is the bandwidth. So we have to have techniques, algorithms, anything else, okay, by which we can efficiently utilize the available bandwidth. Well, of course, when you talk about utilizing efficiently the available bandwidth, means what? Means increasing the number of the users within the same bandwidth. This is our main goal. Okay, so at the beginning, we talk about the beginning. For every service, we are going to allocate or assign a specific bandwidth. So when you are going to increase the number of users, you have to keep in your mind that you have a limited bandwidth. and this bandwidth cannot be increased. Oh, so, or you are going to what? You are going to, for example, go to another service. Well, based on these requirements and these assumptions, it became imperative to restructure the radio telephone system to achieve high capacity with limited radio spectrum, while at the same time covering very large areas. Now, based on these assumptions, now the cellular concept was a major breakthrough in solving the problem of spectrum congestion, well, and user capacity. It offered very high capacity in a limited spectrum allocation without any major technological changes. Now, the idea is what? Is we are going to use the same equipment, okay, the same towers, but we are going to limit the power to a local area. This local area will be called what? Will be called a cell. So the power will be transmitted to the boundary of the cell, and the amount of power or the coverage will not exceed the boundary of the cell. Now, the cellular concept in a system level idea, which calls for replacing, look at, this is the important point. Just we are going to do what? Replacing high power transmitter, okay, or large cell with many low power transmitters, small cells. At the beginning, we have what? We have only single cell, okay? So at that time, we have high towers with high amount of power transmitted. Now we are going to what? We are going to replace this high tower with what? With a smaller towers, okay? And the amount of the power transmitted will be what? Will be reduced again. Now, each providing coverage to only a small portion of the service area, okay? Each base station is allocated a portion of the total number of channels available to the entire system, and nearby base stations are assigned different groups of channels so that all available channels are assigned to the relatively small number of neighboring base station. Of course, I'm going to illustrate this step by step on the whiteboard, but let me complete these 2 points again, and then we are going to go to the whiteboard. Neighboring base stations are assigned different groups of channels so that interference between base stations and the mobile users under their control is minimized. By systematically spacing base stations and their channel groups throughout a market, the available channels are distributed throughout a geographic region and may be reused as many times as necessary, so long as the interference between the co-channel stations is kept below acceptable level. Now let's go to the whiteboard to understand what do you mean by sorry, the other important points. Yes. Okay. Yeah. Connected. More real-time data exchange. Yes. Okay. Full screen. Okay. Now, as you can see here, now let us talk about the initial bandwidth. Of course, we are going to assign or allocate a bandwidth for the, for example, the cellular concept, so cellular communication. Now, we have basic bandwidth. This will be the total bandwidth, okay? Of course, as you know, it ranges about 70 mega, the total bandwidth of the cellular communication system. Now, this bandwidth will be what? Will be divided into what? Into channels, okay? Now, we are going to divide this bandwidth into channels. Of course, as you know, the type of channel will be what? Will be a duplex channel. Well, so يعني two-way communication. typically the channel bandwidth is about 60 kilohertz or 30 kilohertz. Okay, say now we have every channel is about, say for example, 30 kilohertz. Now, after dividing the whole bandwidth into channels, now what we are going to do, we are going to take portions of the what, of the bandwidth. Okay, and so on. Okay, now the bandwidth will be divided into portions. In the idea of the cellular communication system, we have the hexagon shape. Okay, we have a hexagon shape. Look, please. This is a hexagon shape. Now, say this cell is called cell A. Okay, this cell has neighbors. Okay, based on the what? Based on the hexagonal shape. Based on the hexagonal shape, how many neighbors we have? We have 6 neighbors. So this is will be A, B, C, D, E, F, and G. Now we have cell A, cell B, cell C, cell D, E, F, and G. I'm sorry. Such a kind of configuration is called what? Is called 7-cell cluster. Okay, this kind of cell configuration is called what? Is called a 7-cell cluster. Why? Now we have in this cluster we have 7 different groups of channels. So the total bandwidth will be divided into what? Into 7 groups. Say this will be group 1, 2, 3, 4. Of course, the bandwidth will be limited, will be extended up to, say, 5 and 6 and 7. Okay, so we have different 7 groups of channels. Now, say the first portion or group 1, the group 1 will be given to whom? To cell A, and a group, for example, group 2 will be given to B, group 3 C, group 4, 5, 6, and 7. Now here we have what? Here we have different 7 groups of channels are assigned to different cells. Now, please again look at this important point. Now, the whole bandwidth is divided among what? Among these 7 cells. So this configuration is called cellular system. Sorry, cellular system with 7 cells, or cluster size n capital equals to 7. Okay, now this is the what? This is the configuration of the cell. Now let us continue. Now I'm going to talk about the frequency reuse to understand what's going on, or what do you mean by the frequency reuse. Now, how we are going to provide the power? As I have told you before, here, for example, this example talks about what? About the 7 cell. Now, the construction of single cell will be as follows. Look, now I'm going to talk about only a single cell. At the center of the cell or at the edges of the cell. Look, this is another configurations. Or at the edge, we have what? We have the towers, either at the center of the cell or at the edge of the cell. We have what? We have the towers. In other words, look please, these edges or the location at which we are going to install the towers are called cell site. Okay, this will be cell site. The cell site is the location at which we are installing the towers and antennas of the system. It is not the base station of the system. Okay, so either we are going to install the tower at the center of the cell or at the edge of the cell. Now we have illustrated the strategy by which we can distribute and assign the channels for different cells, and we have introduced the cluster size of n equal to 7. Now let's go to the lecture, continuing the PowerPoint slides. Yes, neighboring base stations, as I have told you, are assigned different groups of channels so that the interference between base stations and the mobile users under their control is minimized. By symmetrically spacing base stations and their channel groups throughout the market, the available channels are distributed throughout the geographic region and may be used as many times as necessary. But we have to keep in our mind the level of the interference must be kept at acceptable level. Now, cellular radio system rely on an intelligent allocation and reuse of channels throughout the coverage region. Each base station is allocated a group of radio channels to be used within the small geographic area called what? Called cell. Now, again, base stations in adjacent cells, for example, cell A and B, as I have told you before, as I've explained for a while. Okay, we said that we have 7 cells, and cell A is assigned, for example, group 1, cell B is assigned group 2, so there is no interference between the adjacent cells or neighboring cells. The base station antennas are designed to achieve the desired coverage within particular cell. Okay, this is the important point. Always we are going to to adjust the amount of power in a way that the power will not exceed the cell boundary. The base station antennas are designed to achieve the desired cover within the particular cell. Now, by limiting the coverage area to within the boundaries of a cell, the same group of channels may be used to cover different cells that are separated from one another by distance large enough to keep interference, co-channel interference, I mean, levels within tolerable limits. Now, when we are going to reuse the clusters or reusing the frequencies, we have to keep a distance which is called co-channel reuse distance. This distance will be physically used to apart between two cells which have the same channel sets in order to what? In order to minimize the co-channel interference. The design process of selecting and allocating channel groups for all of the cellular base stations within a system is called the frequency reuse or frequency planning. Now, look please at this graph. Really, in this graph, we are going to illustrate a very important points. Look please. We said that at the beginning, let us determine the cluster size. As you can see, here we have A, B, C, D, E, F, G. Again, the same letters are repeated here. Look, A, B, C, D, E, F, G. And again, the same letters are what? Are repeated here. Now, at the beginning, I'm going to talk about the cell A. Look, please, the cell A. Here we have cell A, and cell A. These 3 cells, look please, these 3 cells carry the same frequency channels, okay? Carry the same frequency channels, or we have allocated the same groups of frequencies to these 3 cells, Okay, now what we are going to do now we said that the power transmitted from the base station of cell A will be what? Will not exceed the boundaries of the cell A. Okay, look. So the power will be locally distributed, okay, over what? Over the area of cell A. Now if you are going at this point, okay, now we are going to travel from cell A to cell F. Well, at this point, of course, we don't have power of cell A. Why? We said that the power will be transmitted in a way that it will not exceed the boundary of the cell A. Now, so after a distance, okay, after a distance, of course, this distance will be calculated using a mathematical formula. A distance which is called co-channel distance. Now we can what? We can repeat the same cell. Okay, repeat the same cell. Of course, this cell will use the same frequency groups. Again, for this cell A, so in this graph or this figure, we have used 3 cells of the same channel set, and there is no interference. Why? Due to what? Due to the local power distribution. Of course, the same story will be done with whom? B, 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 and B, C, 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 okay? For all the cells in the system. Now another question. How many clusters we have in this figure? Really, we have what? We have 3 clusters. Okay, as you can see, bolded line, okay, describes the cluster. Of course, this cluster consists of 7 cells. Another cluster, 7 cell. Another cluster, 7 cell. So in this figure, we have repeated, okay, the cluster 3 times. The cluster is repeated 3 times. Now, we said that every cluster consumes the whole bandwidth. Every cluster consumes the whole bandwidth. So in this figure, how many bandwidths we have? How many bandwidths we have in this figure? عليه جماعات؟
سيدي منار حفتن؟
لا حافت أو حافت سلميت هين باشا؟ لا من قلت أنا سر وايد بوردي من شو قلت أنا؟ من قلت أنا ما هي total bandwidth نا اف total bandwidth ام دبلانف كي لسر cell of the cluster الفيري ما كان سيل هي نوف كلاستري او كلاستر كان سيل تدايا حفته نا
حفتن.
Okay, now this cluster represents what? Represents the whole bandwidth. نا هذا bandwidth كامله الفيري الفيري كامله افجي كامله يعني انه كما كان bandwidth يا هي
دكتور سنة
عفرم 3 bandwidths بس براستي او تشته ما هي اك bandwidth نا بس due to frequency reuse, okay, due to frequency reuse, single bandwidth becomes what? Becomes 3 bandwidth. Oh, it's very good. Now we can imagine the following. Let's go to the whiteboard, please. Again, now this will be the frequency reuse block. Okay, now the input to the frequency reuse block will be what? Will be single bandwidth, 1 bandwidth. The output, of course, in this figure becomes what? A 3 by bandwidth. Now, can anyone tell me what we can conclude from this operation, please? What we can conclude?
Increase number of users.
Yes, number of users increased. But why the number of users is increased? Yes, you are talking well.
the number of channel is increased.
يعني باندويث كأنما باندويث زيادة بتنا.
بلى.
Okay, now look, single bandwidth at the input of the frequency reuse, the output becomes what? Becomes 3 by the bandwidth. Oh, good. Of course, when we have talked about this figure, in this figure we have what? We have 3 clusters only. رجاء بس بري خوبدن ما بيسارك هينوكا. بس بري خوبدن. Now, assume that we have a system. This system has, for example, 5 clusters. Okay, this will be cluster number 1, cluster number 2, 3, 4, and 5. Now, can anyone tell me what will be the output bandwidth?
5 bandwidth. 5. Each cluster have bandwidth.
Yes. So in this time, Jay, good. So in this time, due to frequency reuse, okay, we have single bandwidth at the input, but actually, just as we have what? 5 bandwidth. Really, we are using what? We are using only 1 bandwidth, which is allocated by the government, okay? But due to the frequency reuse, the number of channels is increased, and due to what? Due to the local power distribution, okay? Keep in your mind this important point. In the cellular communication, we are talking about what? Local power distribution. And the power will be what? Will be used to cover the cell without exceeding the cell boundary. This is about the concept of what? The concept of frequency reuse. Now, let's continue. Now, to understand the frequency reuse concept, consider a cellular concept. Now really, I'm going to derive a formula for the system capacity of the cellular communication system. Well, consider a cellular system which has a total of S duplex channels, well, available for use. If each cell is allocated a group of K channels, now look, if each group of each cell is allocated a group of K channels, now K is less than S. Now my question is, why K is less than X, and what will happen if K equal to S? Again, the total bandwidth has S duplex channels, okay? Now we are going to assign or give each cell a group of K channels. The condition is K must be less than S. Now my question is, if K equal to S, what will happen?
دكتور interference بت بينهم.
لا خير، لا أبناء interference. بس بري خوبدن درس بري خوبدن جماعات. ما هي S duplex channel أبد شيء أبد total bandwidth باشا. نوكا we are going to assign or give each cell a group of K channels. K is less than S. My question is, if K equal to S, what will happen?
No change in channel, number of channel.
يعني شيء واضح هذا، يعني شيء no change in number of channels. It's not
يعني
clear.
زي دنابت هر channel كذا دنابت يعني.
Why؟ يعني بوشي دي زي دنابت.
ما ideal يعني لو باس فلترين دوكو سيجنال ما كو ريكفر كان.
لا هذا لا. more opinions. أري جماعة.
Should this backup bandwidth here limited?
ها
Backup bandwidth here limited?
bandwidth limited طبعا يعني bandwidth limited number of channels يعني bandwidth او S channel تداية S duplex channel تداية. okay, we are going to give every cell K channels يعني هذا S total S وهر cell لكي K channels يا هاي انه كان بصار من تشته او شرطك شيء شرطك اگر K كم ترش S باشا. now if K equal to S اگر K equal to X what will happen شو تشد
N will be 0.
oh you are wonderful N equal to 0
بله دكتور.
تكيه نافيتا
بله.
شيء نافيتا شيء كيف
آيسن.
ها
آيسن دكتور.
اي لا واضح هذا ايسن
بله.
affirm ايسن. if K equal to S, if K equal to S, it means we are going to allocate the whole channels to what? To single cell. At that time, we don't have clusters and we are going to what? And we don't have the ability to what for using the frequency reuse. Okay, it's a very important point. Well, now if K equal to S, this means we are going to what? We are going to allocate the whole channels to what? To a single cell, and at that time we are going back to the what? To the early of the wireless communication generation. Okay, so K must be less than S, and if the S channels are divided among N cells, as you know, in the previous example on the whiteboard, we have divided the whole number of channels among 7 cells. Okay, we said that at that time N equal to 7. Of course, we have different cluster sizes. Cluster size may be 4 cells, maybe 3 cells, maybe 7, maybe 9, maybe 12, of course, according to a specific equation again. So among N cells, I mean among the cells of a cluster into unique and disjoint channel groups, which each have the same number of channels. The total number of available radio channels can be expressed as S equal to K by N. Look, please, we said that we have K channels. يعني مثلا, okay, for example, say you have 300 channels. Okay, say you have, for example, maybe say, for example, 300 channels. Now, what we are going to do, and let the cluster size N and let the cluster size N equal to 4. Okay, now 300 divided by 4 will be what? Will be 75. So by now in this example, K will be what? K will be 75. Every cell is given what? Is given 75 channels, and we have 4 cells at that time. The overall number of channels which is given for the system S will be 75 multiplied by 4, which be what? Which will be 300. Of course, this kind of allocation or channel distribution is called what? Is called uniform channel assignment or uniform channel allocation. The important thing here, the overall number of channels is equal to K multiplied by N, and K represents the number of channels assigned to a single cell, and N capital represents the cluster size, I mean the number of cells for each cluster. Well, now look please. Now the N cells which collectively use the complete set of available frequencies is called what? Is called the cluster. Really, I have explained this idea at the beginning of the lecture. Well, we said that the whole bandwidth channels will be assigned to whom? To the cells of a single cluster. Now look, if a cluster is replicated or repeated m times within the system, the total number of duplex channels C can be used as a measure of the capacity, and is given by C equal to what? C equal to MKN and equal to what? MS. Of course, S represents what? Represents the number of channels within what? Within a single bandwidth. And M represents what? Represents the number of times by which we have replicated the clusters. Just as talking what? M bandwidth, okay? M bandwidth becomes. So the and we are when we talk about the capacity, we are talking about, for example, the number of channels or users. So M will be multiplied by S. S represents the number of duplex channels in the system. Now, notes. We have some notes. As seen from equation 3.2, the capacity of the cellular communication system is directly proportional to the number of times a cluster is replicated. So when in a fixed service area, the factor n is called the cluster size and typically equal to 4, 7, or 12. Of course, we have 3 and 9 again. Regarding to the point number one, of course, if we have the ability to minimize the cluster size at that time to cover the same area, we are going to more repeat the clusters, hence increasing the capacity of the system. If the cluster size is reduced, okay, now say moving from say 12 to 4, while the cell size is kept constant, more clusters are required to cover a given area, and hence more capacity, a large value of C will be what will be achieved, of course. Now, a larger cluster size causes what? Causes the ratio between the cell radius and the distance between co-channel cells to decrease, leading to what? To weaker co-channel interference. Conversely, a smaller cluster size indicates that the co-channel cells are located much closer together. Of course, this point needs the whiteboard. Let's go to the whiteboard to illustrate what we are talking about. Yes. Full screen. Okay. Now, look, please. We said that this is a large cluster size. Okay. Again, this is a large cluster size. Say we are talking about cluster size of 7, for example. Now, cell A and cell A. Now, this is a physical distance. Okay, physical distance between these two cells. Okay. Of course, the most important thing for us to measure the distance between the cells which have the same channel set. For example, here I'm talking about A, and here is A again. So these two cells have the same channel set. Now, the most important thing is to provide physically to provide sufficient distance between these two cells. Okay. Now, when we talk about, say, for example, smaller cluster size, say cluster size of 4 cells. Okay. Again, we have cell A and cell A. In this time, as you can see here, the D is smaller than the D of the 7 cells. Okay. Now, this D is smaller as compared with the D of 7 cells. So considering smaller cluster sizes, yes, will enhances the capacity of the system, but what? But will lead to increasing the interference, which is not a desirable point. Okay. So when we are going to design a cellular communication system, what we are going to do, we have to make a trade-off. Okay, we have to make a trade-off between what? Between the system capacity and the channel interference. Okay, we have to make the trade-off between system capacity and co-channel interference. Keep in your mind two important things from now on when we are going to design a cellular communication system. First point is the system capacity second point will be co-channel interference. Now, if n is large, okay, large values of n, large values of n means what? Means interference is decreased. While small values of n means what? Capacity is increased. Okay, this is the two important extremes we have in the what? In the cellular communication system design. So we have to make a trade-off between the system capacity and co-channel interference when we are going to select the cluster size in order to what? In order to select a suitable cluster size for the system design. Now, do you have any questions up to this point or not? Ali Jamaat? No response. Is everything clear?
لا دكتور تمام.
تمام دكتور تمام.
تمام باشا. Okay, now we need to take a rest for 10 minutes, and then we'll go back to the second hour of the lecture. Thank you, and see you after 10 minutes, inshallah. Stop sharing.